Hello, everybody. So in this section, we're looking at 2.8, Objective 2. We're not only going to be graphing inequalities, but we also need to figure out how to solve them. The rules you should pay attention to is what happens when you have to move numbers from one side of the inequality to the other side, when you're adding, subtracting, versus when you're multiplying and dividing. There's some special rules there that you need to pay attention to.
Keep in mind our definition of linear inequality in one variable, and notice this is a linear inequality in one variable. I'd like to solve this linear inequality for x. We need properties of inequality to solve, just as we had properties of equality to solve linear equation. Let's look at our first property. We'll call this property the addition property of inequality, and it will remind you of the addition property of equality. If A, B, and C are real numbers, then A is less than B and A plus C is less than B plus C are equivalent inequalities. What does that mean? That means we can add the same number to both sides of an inequality, and the result is an equivalent inequality. Remember, subtraction is still defined in terms of addition, so we can also subtract the same number from both sides of an inequality. The result is an equivalent inequality. Let's solve this linear inequality. We're solving it for x. And just as for equations, we do want x by itself on one side of the inequality. So notice if I add 2 to both sides, I will have x by itself. So here's the left side of my inequality, and then I'll leave a little space, and there's the right side. I will add 2 to the left side, and I'll do exactly the same thing on the right side. And notice what happens on the left side. I have simply x, and then greater than or equal to, what is negative 7 plus 2? That is negative 5. So all numbers greater than or equal to negative 5 are solutions. Let's graph the solution and then write the solution set in interval notation. So greater than or equal to, do we place a bracket or parenthesis on negative 5? For greater than or equal to or less than or equal to, we place a bracket. Now I'll be shading to the right because I'm shading all numbers greater than or equal to negative 5. So I'll face the bracket in this direction, and then I'm shading all numbers greater than or equal to negative 5. There is the graph of the solution set. Let's now write it in interval notation. Remember, just write the shading from left to right. So the shading begins at negative 5 with a bracket, and then we go all the way to positive infinity or simply infinity, and we always place a parenthesis about positive or negative infinity. Here is our solution set in interval notation. Now, we have an addition property of inequality. Doesn't it stand to reason that we also have a multiplication property of inequality? But before we look at that multiplication property of inequality, let's look at a few examples dealing with multiplication. For example, I know that negative 2 is, say, less than 5. That is a true statement. Let's multiply both sides of this inequality, say by a positive number, 3. Let's multiply the left side by 3 and the right side by 3. And my question is, does this inequality remain the same? Well, let's see. 3 times negative 2 is negative 6. Is this the same? 3 times 5 is 15. Is this still a true statement? The answer is yes, because negative 6 is less than 15, so we can multiply both sides of an inequality by a positive number. Now let's try this with a negative number. Same true inequality. Let's multiply the left side by a negative number, say -3. And let's multiply the right side by a negative number. Now, the left side becomes +6, the right side becomes -15. So does that inequality symbol remain the same? The answer is no, because this is a true statement. If I kept the same inequality symbol, that would be a false statement. How do we keep a true statement going then when we multiply both sides of an inequality with a negative number? We do so by reversing the direction of the inequality symbol. By reversing the direction, we keep a true statement. So let's look at the following multiplication property of inequality. And it's in two parts depending on whether we are multiplying by a positive or negative number. If A, B, and C are real numbers and C is positive, then A is less than B and A times C is less than B times C are equivalent inequalities. Now watch what happens if we multiply by a negative number. If A, B, and C are real numbers and C is negative, then A is less than B and A times C is greater than B times C are equivalent inequalities. Now let's practice using that multiplication property of inequality. I'd like to solve this linear inequality in one variable. To solve this, we want x by itself on one side of the inequality. So I will divide both sides of this inequality by the coefficient of x, which happens to be a negative number. So here's the left side, here's the right side. I'll divide the left side by the coefficient of x and the right side by the coefficient of x. When you multiply or divide both sides of your inequality by a negative number, you must reverse the direction of your inequality symbol. Since I'm dividing by a negative number, this is reversed. And now let's simplify. The left side is simply x, just like I want, greater than or equal to 16 divided by -8 is -2. So all numbers greater than or equal to -2 are solutions. Let's go ahead then and write down, or let's first graph it. All numbers greater than or equal to -2, I place a bracket on -2 and I shade to the right. Now let's write it in interval notation. Just write down what you've shaded from left to right. So it'll be bracket, -2 to infinity, and then don't forget you place a parenthesis about infinity. So there's the graph of my solution set, and there it is written in interval notation. All right, keep that multiplication property in mind, and let's solve this linear inequality.
Okay, guys. So I want you to try to solve this one on your own. What you're going to need to do is solve the inequality just like she did the previous one, and then graph it on the number line. If you need help, let me know.